Hello everyone, welcome to today's class. This is Teacher Simon taking you through Written Statistics 1, paper 9709/55 for May, June 2025, and this is part 1 for questions 1 to 3. This is the first of its kind for us to have variant 5. We have always had variant 1, variant 2, variant 3, but there is also now variant 5, starting with this May, June 2025. So maybe probably the regions have become very many, and then there is this variant 5. Question 1. Two fair six-sided dice with faces labeled 1, 2, 3, 4, 5, 6 are thrown. The two scores are noted. The random variable x is defined as follows. If the two scores are equal, then x is equal to 0. If the scores are not equal, then x is the largest score minus the smaller score. Part A, draw the probability distribution table for x. Now we are going to draw the possibility diagram first, then we use that to get the probability distribution table. So we have two dice. So we have 1, these are the scores, 2, 3, then 4, 5, and 6. Even the other one has 1, 2, 3, 4, 5, and then 6. So I'm going to put all of these ones in a table. They say that if the two scores are equal, then x is 0. So 1, 1 is a 0, 2, 2 is a 0, 3, 3 is a 0, 4, 4 is a 0, 5, 5 is a 0, 6, 6 is a 0. And then if they are different, then x is going to be larger minus the smaller one. So 2 minus 1, that's a 1. Here we shall have a 2, 3, 4, 5. Here we shall have a 4, a 3, a 2, a 1. Remember, I'm getting this big one, then minus, for example, the smaller one to get this one, okay? Then here we shall have 1, then 2, then 3, 4, 5. This will be 4, 3, 2, 1. This will be 3, 2, 1. This will be 2, 1, 1, 2. This will be 1. This one is going to be a 1, and 1, 2, 3. So that is what we are having there. Now we need to find probability distribution table, right? Yes, from here. Now I have x here, and then probability of x is equal to x. So we can see a 0, there is a 1, there is a 2, there is a 3, there is a 4, and then there is a 5. So we put now these ones in the table. So zeros, we can see this is 1, 2, 3, 4, 5, 6. Out of the outcomes are, you get 6 here times 6, which is 36. So this one is going to be 6 out of 36. And then for 1, we see 1, 2, 3, and 4, 5, 6, 7, 8, 9, 10. So those are 10 out of 36. Then 2s, we're seeing 1, then 2, 3, 4, 5, 6, 7, 8. So we shall put 8 out of 36. Then 3s, 1, 2, 3, 4, 5, 6. So that will be 6 out of 36. You can simplify them. On this one, you write 1 over 6, no problem. This is 1, this is 2, this is 3, this is 4. So we have 4 4s. 4 out of 36. And then 5s, we have 1 here, and then 2 here. So that is 2 out of 36. Suppose we try to add the probabilities. Do we get a 1? This is 16, then 24. 24 plus 6, 30, 34, 36. So 36 out of 36 is 1. So that's a probability distribution. Part B, we are supposed to find the expectation and then the variance. Okay, now what I'm going to do here is to duplicate this one. Just bring it down here. And then I'm going to add on 2 rows. One row is for x times probability of x is equal to x, because we shall need it for this one here. And then the other one is for x squared times probability of x is equal to x, because we shall need it for the variance. These ones multiplied, we have a 0. Then here we have 10 over 36. Then here 16 out of 36. And then here we shall have 18 out of 36. 4 times 4 is 16, 10 out of 36, and then 10 out of 36. Then here the total summation of x, then probability of x is equal to x. What shall we get here? 16 plus 16, that is 32, plus 18, that will be 50. Then plus 10, 60, then 70. So this one gives me 70 out of 36. Then here we shall need summation of x squared, then probability of x is equal to x. Now, 0 squared times this one here, we shall get a 0. 1 squared times this one here, we shall get 10 over 36. Then 2 squared is a 4. Then times this one here, 4 times 8, that will be 32, and out of 36. Then this one squared is a 9 times 6. I think that's a 54 over 36. And then this one squared is 16 times 4. Isn't that a 64? That is a 64 out of 36. Then 5 squared is 25 times 2. That will be 50 over 36. See? Then when we add these ones here, we shall have 50 plus 54, that's 104. 104 plus 32, that's 136. Then 146. 146 plus 64, that is 210. So I'll have here 210 out of 36. Now, the expectation or the mean is equal to the summation of x, then probability of x is equal to x, which is equal to 70 out of 36. Okay, if you want, you can simplify it. We write to 3 significant figures by 235 by 218. And then the variance of x is equal to the summation. We actually get e x squared, then minus e of x here, then brackets squared. And this one here is the summation of x squared, then probability of x is equal to x, then minus the summation of x, then probability of x is equal to x, then after square that. So what do we have here? This is 210 out of 36, then minus 70 out of 36, then bracket squared. Then all together, what do we get? 210 out of 36, then minus, we have 70 out of 36, then bracket squared. We shall get that fraction there, but to 3 significant figures, we can write it as 2.05. 2.05. 3 significant figures. As simple as that. Question 2 is coming from normal distribution. The heights of trees in a certain forest are classified as tall, medium, or small. The heights can be modeled by a normal distribution with mean 20 and standard deviation 5. Trees with a height of less than 14 meters are classified as small. Part A. For 150 randomly chosen trees from this forest, how many would you expect to be classified as small? Now remember, those that are classified as small, they say their height is less than what? 14. So that means I will have probability of x less than 14, right? Which is going to be equal to, then we standardize this one, z less than, remember z is equal to x minus mean out of the standard deviation, right? So we shall have our x here, which is 14, then minus the mean, which is given as 20, standard deviation is given as what? 5. And this one is going to be probability of z then less than the negative 1.2. Okay, now in the normal distribution, in the table, they actually give, there's somewhere they talk about this one of the negative. So the negative 1.2 is here, and we want that probability, which is less than it. So this is the region, okay? But this same region is actually the same as, let me read, let me draw this one again, like that. So it is the same as this other one that is positive, greater than this one of the positive. You see, these two are the same. Remember, the mean of the standardized normal distribution is 0, okay? So this one here is the same as this. You see that? So meaning we can have this one equal to probability of z then greater than the 1.2. Because remember, in the table, you don't have probabilities for the negative z values, but then the one that is given is for the less than. So how do we get this one here? It will be the total probability, which is 1, then minus this one for the less than. You see that? So 1, then minus probability of z less than 1.2. So when we go to the table, we can read off this value 1.2. When we come to the normal distribution table that is given in the list of family, we are looking for 1.2, which is here. So 1.2 is the same as 1.20. That means this is the one we are taking, 0.8849. 0.8849. Now 1 minus 0.8849, what does it give us? 1 minus 0.8849. That is 0.11, 0.1159. Here I've used a table, but you can also use a calculator, and I've always guided you on how to get this answer from the calculator, and I can just get this right away. It is less than, I use the p, right? So when I come to the calculator, I make sure that start comes on the screen. So I'll press mode, and then start is 3. Then after, I press this SC button, and then from there I will press shift, then 1, then distribution is 5, that is normal distribution, so I pick option 5, and then P, I've already said it is for less than, R is for greater than, okay? So this one is for less than, I'll pick P, which is option 1, and then I'll put that negative 1.2. Just put it as it is. You see, the answer we are getting is 0.11507, but to 4 decimal places the calculator gives, you are going to get 0.1151. By the way, pardon me here, this one has to be 51, not 59. Okay, so let me just write, this one is equal to 0.11507 from the calc. Okay, so you can also do that, and then from there you get this one, then times what we are supposed to multiply with here to get the expected number. So expected number of trees is going to be equal to, you get the probability you have gotten, okay, then times the number of trees that are randomly chosen, 150. So what do we get when we multiply everything here? 0.1151, then times 150, we get 17.265. That means we can write our answer as 17 or 18, okay? So you can have 17 full trees, you get it? But you cannot have 0.265 as a tree. So you can either say 17 or 18, but in the exam, don't write like this, okay? Just pick one. And I recommend you always take the full one, okay? You take the smaller one, 17, as simple as that. Then here they are saying trees from this forest are classified as tall if their height is at least here means greater or equal, okay? At least h meters. 25% of the trees are classified as tall. Okay, now they say 25%. So I will say probability of x is greater than h. I can put greater or equal, whatever. Okay, normal distribution, this is continuous, so it is the same. This is 0.25. Okay, now I need probability of z maybe greater than z1, okay, to give me that 0.25. Remember, I have always said that before you continue with finding the z value, always sketch these barrel-shaped curves. Sketch 2 of them and then try to judge, because z value can be a negative or it can be a positive. So which of them is the one we are going to take? So greater than, we are looking at the right of the z value. So if I look at this one here, and then we come to this one, we also look at this, you ask yourself, which of these two can give me the 0.25, these regions? This region here must be greater than 0.5, because we know that half, if this is the mean, that is 0, half of this is 0.5. You see, this is 0.5. That means there is something that we are adding here. So the whole region here is giving a value of the probability that is greater than 0.1.5. That means this one is off, but this one is okay, because if this is 0 and this whole thing is supposed to be 0.5, then this region has to be less than the 0.5. Okay, so this is 0.25. Now that means our z value is therefore a positive, okay, is not a negative. All right, so this is the one we are taking. So z1 is going to be the phi inverse of the 0.25. But again, on our normal distribution table, we don't have probabilities that are less than 0.5, because what we are given is the curve for less than the zn value of z, less than. So this one has to be greater than 0.5. You see that? So the list is going to be the 0.5. Now, since z is just a boundary, it is just a boundary between the two regions. One region is giving a probability that is maybe greater than 0.5, and this one is less than 0.15. So we shall instead use the bigger region, okay? The bigger region. So we shall say 1 minus the 0.25, which is going to be 0.75. Then we go to our normal distribution table, and then we look for this 0.75, and then the z value that corresponds to it. When we come here to the table that is given, 0.75 is around here, okay? But before you do that, okay, before you do that, you look for the z values. Always come down here. There is a small table here for a few critical values, okay? Now 0.75 is already here. That means the z value is 0.6714, okay, 0.674. And also we looked at this one here, and I said that it must be in between where? It has to be around here. So you take this small one here, which corresponds to the 0.6, then 7, 0.67. What are they adding on to this one to get to the 0.7? To get to the 0.75, it will be a 14, right? So if it's a 14, then I can go to this other side and then I look for the 14. You see? So 14 is in between here, 16 and 13. Maybe you take this one here. So you take the smaller one that is closer to the 14, and there is a 4. So you'll get the 0.674, which you see here in the table that's already given. So always check in the table here, okay, before you go to any other. So this one is 0.674. If the z were a negative value, then we would put a negative on it, okay? All right. Now, again, we know that z is equal to x minus mu out of the standard deviation. So our z is 0.674, which is equal to the x value. Now is going to be this h, then minus the mean. Mean was given as, was it 20? Yes, mean is 20. Standard deviation is what? 5. So 20. And then the standard deviation here is 5. So if we cross multiply, we shall have 0.674, then times the 5. Then this one is equal to h minus the 20. So if I take 20 to this other side, we shall have h, which is equal to 20, then plus 5, multiplying 0.674. And then finally, we get our answer as h, which is equal to 20 plus 5 into 0.674. So we get 23.37, 23.37, or you can write 23.4 to 3 significant figures, as simple as that. Question 3. In a certain large school, on average, 2 pupils in 5 have music lessons. A random sample of 80 pupils from this school is chosen, but use an approximation to find the probability that fewer than 27 pupils have music lessons. P is 2 in 5, and then that means our Q is going to be 3 in what? In 5, okay? Our N is 80. So we are supposed to find probability of X less than what? 27. That means you'll have 26, 25, 24, 23, 21. When will you end? It becomes hectic. So we approximate the binomial distribution to the normal distribution. When we approximate the binomial distribution to the normal, we need 2 things here. Number 1 is to find the mean and then the standard deviation. So mean is equal to NP, because you need mean when you are, you need mean and standard deviation when you are calculating in normal distribution, okay? So our N is 80, then our P is 2 out of 5. Of course, when I multiply here, 5 goes into 80, 16 times. So 16 times 2, that will be a 32. And then the standard deviation is root of variance, but variance is given as NPQ, which is equal to the square root of 80 times 2 out of 5, then times 3 out of 5. Okay, so this is 32. 32 times 3 over 5. 32 times 3 out of 5. We get 96 over 5, which is 19.2. So I'll leave it exact. 19 point what? 0.2. Now, before we even find this one here, the other thing we need to do, because I told you we need two things. Number one is to find the mean and the standard deviation. Then the other, we carry out continuity corrections. We carry out continuity corrections. We do this because we are moving from discrete random variables to continuous random variables. When it is binomial, here we are dealing with discrete random variables, and then in normal distribution, we deal with continuity corrections. I mean with continuous random variables, and here we use bounds of numbers. So here we are having a 27, okay, a 27, and then the next number in line has to be a 28. Then the number before is a 26. In your O level, you did what we call upper bounds and lower bounds, not so? So there is a lower bound for 27 and there is an upper bound for 27. This is 26.5 and this is 27.5. When you round this one off to the nearest whole number, it is going to give you the number next in line, that is 28. It is no longer going to give you this one here. So that means when we are writing this 27 is less than the 27.5, but here we have less than or equal to 26.5, because when you round off all the numbers that are here, they will give you the 27. But even here, but this one here gives you the 28, so that's why we put what? Less than. Now, when we are doing continuity corrections, we are either taking this lower bound or the upper bound, okay? So if this one is less than, that means when we get those values and we round them off, okay, and we round them off, what we get is below 27. What we get is below 27. That means we have to get this region here below this 26.5. Not so, because any number that you are going to get here and then you round off, it will give you the 26. You get it? Not 27. So that means that's why I always say that if they give you less than, you always subtract a 0.5. Okay? If it is less than or equal, you add a what? A 0.5. Then if it is greater than, you add a 0.5. If it is greater than or equal, then you subtract a 0.5. As simple as that. So that means this one will approximate to probability of x, then less than 26.5. Then we standardize. We have, remember, z is equal to x minus mu out of the standard deviation, right? So our x now becomes the z, then now less than. We standardize this, it will be 26.5, then minus mean, which we have gotten as what? 32. Then we divide by the standard deviation, root of 19.2. So if you put this in the calculator, you write your answer to 3 decimal places, okay? Then you can go to the table and then you look for it. But I'm going to do all of this on a calculator because we can get this from the calculator straight away. 26.5 minus 32, we are getting negative 5.5. So it's probability of z less than negative 5.5 out of the square root of 19.2. Now we have to put our start on a calculator mode, then start is 3, then you press AC, start comes onto the screen, then shift 1, distribution is 5, and this is less than. So if it is less than, then we are taking P. So that is option 1. Now we can put negative 5.5, then divide by the square root of 19.2. Okay, we close the brackets and then we also close that. We have 0.1047. 0.1047. So I can write it to 3 significant figures, which is going to be 0.105. Okay, 3 significant figures, as simple as that. Then here they are saying that a random sample of 10 pupils from this school is now chosen. The number of the students is now known. Find a probability that no more than 2 pupils have music lessons. So this is a binomial. This is clearly a binomial distribution. Okay. Why? Because n is fixed. Okay. And the outcomes are independent of each other. We have the success and then the failure. So our P, remember, is 2 out of 5. Our Q is 3 out of 5. And now our N is given as what? 10. So we want probability of X less than or equal to 2, because they said no more than 2. So that is less than or equal. Okay. And then after that, we are going to have this one is equal to, we shall get X is equal to 0. We shall get X is equal to 1. And then we shall also get X is equal to what? To 2. So that means this one will be 10, then combination 0. And then our P is 2 over 5. The 0 that is here, those are the number of times we are getting the success. Okay, so it is 0. It is the one that we power here. And then we have 3 over 5. That means this one will be to the power of 10. Because when you add these two, they should be in position to give you the n. Okay. Then the next one, it is going to be 10 combination 1. And then this will be 2 out of 5 power 1. And then 3 out of 5 to the power of 9. Then lastly, we have 10 to the 10 combination 2. And then 2 out of 5 power 2. And then 3 out of 5, then power 8. When we put all of these ones in the calculator, what do we get? 10 combination 0 is, of course, 1. 2 over 5 power 0 is 1. So here I just have 3 out of 5, then power 10. And then the next one, 10 combination 1, that is a 10, then times, this will be 2 out of 5, and then times, we have 3 out of 5, then to the power of 9. Then after that, we go to the next one, 10 combination 2, that will be 10 times 9, 90 divided by 245. That will be 45, then times, this will be 4 out of 25, then plus, we shall have 3 out of 5, then to the power of 8. To the power of 8. Pardon me, here I'm supposed to multiply. And then we get our answer as 0.167 to 3 significant figures. 167 to 3 significant figures. That is that. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.